This video is to show how to use STAAD.Pro to draw the shear and the moment diagrams of a frame. And today's example has 4 nodes, A, B, C, and D. And this frame has a fixed support at A, pinned connection at B, and pinned connection at C, and pinned support at D. This frame is subject to a lateral pressure 0.8 kPa on member AB and has the nodal load 3K on node B and node C. Also have the concentrated load 6K on member BC. So now we open the STAAD.Pro software, and the first thing to do is configure to make sure the base unit match the original model. And for this example, we have the kip and the foot, so we need to change the base unit to English and keep the remaining default. Click OK. Then we'll do a new model and then put the model information, file name, and location to save the files. Then check the type analytical and the unit system is English. Now go to the job information. And for the job name, I put STAAD session 4. And this one is frame, shear, and moment diagrams. And put client RIT. Job number is the course number. The reference is the frame, shear, and moment diagram. Class example. And then put your name and engineer and the date. The command is to use STAAD to draw the shear and moment diagram. Of a frame and compare the results with hand calculations. After that, we click Create. And we'll enter this analytical modeling window. Then we will do the input of geometry, properties, materials, specifications, supports, loading, and analysis. We will be done at analysis. And before we do the geometry input, we need to make sure our input unit match our original model. So we need to check at this right bottom corner, input unit currently set keep feed. And if does not match your original model, we need to go to input unit and enter English system and check foot and kilopound and click apply. Then we can input the 4 nodes in this example. And we have 4 nodes. The first one is 0, 0, 0. Second is 0, 15, 0. And node 3, 24, 15, 0. And node 4 is 24, 0, 0. So we just manually input the coordinate of each node. After that, we want to change the view just to the XY plane. So go to the View tab and select this Front View button. And now we just see the XY plane. After that, go back to Geometry and select the Add Beam button and connect the nodes to draw the beams. So node 1 to node 2, node 2 to node 3, node 3 to node 4, and escape. And for this model, I want to show the node number and the beam number. So I just put my mouse in the screen and right-click and select Labels. And under the Labels tab, select node numbers, node points, and beam numbers. Then click OK. So now you can see those nodes shown on the screen. And after that, we're done with geometry and go to Properties. And for the properties, for this example, we'll use W18 by 35 for the beam, BC, and W10 by 60 for the column AB and the column CD. So now we need to create these two sections. Using section database, then in this section profile tables, select Steel, W shape, and first select 18 by 35 and do Add, and then do 10 by 60 and Add, then close. After that, highlight this W18 by 35, use cursor to assign to member 2, and escape. Then highlight 10 by 60 and use cursor to assign to member 1 and member 3, and escape. So now we're done with properties and go to materials. Since we assigned W shape, so the program will automatically set the material as steel, and we just accept it and go to specifications. Specifications is the place to release the moment at hinge connection. So we have two pin connection in this example as node 2 and node 3. So we need to release the moment at these two nodes. Using beam button and then release. And first the location, we'll put location at the end because node 2 is at end of member 1 and node 3 is at end of member 2. So first we do the location end and release MZ and do add. Then we select the beam again and location start and release MZ. Because this hinge connection is at the start of member 2 and start of member 3. So we just add it. After that, we highlight this end MZ and use cursor to assign to member 1 and member 2. And then escape and select those beams. And then highlight start MZ, use cursor to assign to member 2 and member 3. And escape and select the beams. So now you can see that the small circles at node 2 and node 3. So we successfully release the moment at these two pinned connections. Done with specifications and move to support. For this example, and we have a fixed support at node 1 and pinned support at node 4. So first we need to create a fixed support. Let's select the fix and do add, and then create again. Select the pinned support and do add. Then highlight this fixed support. Use cursor to assign to node 1. Escape and select the pinned support. Use cursor to assign to node 4. And escape. Now we're done with supports and move to loading. And based on the example, we assume that this load case is a wind load case. And we have the wind pressure on member 1 and also have the compression on member BC. So now we need to define a load case and then add load items. So under this load case details, we do add. Loading type, we select wind, and title, just put wind load. And do add. After that, you should see a wind load under this load case details, and we can close. Now highlight this wind load case and do add. Now we need to add load items. And the first load items that we'll do is the pressure on member 1. So it's a member load, uniform force. The magnitude is 0.8. Keep per foot in the GX direction, global X direction. That's the lateral pressure on member 1. And since this pressure occupied the entire member, and we can leave D1, D2, and D3 as 0. And after that, we just add this load item. Don't close this window. Now we move to nodal load. Define the nodal load directly on node 2 and node 3. So for node load, select a node. The magnitude is -3. -3 keeps in the Y direction. And we just add it. And after that, we need to define the member load, concentrated force. And the magnitude is -6. D1 dimension, that is the dimension from the point load to the member start. So the first 6 kip load is 8 feet from member start. In the GY direction, -6 means downward direction, and we do add. And then just change the D1 to 16 of the second concentrated load, and we do add. After that, we finish all those load items, cover all those load items, and now close this window. Now we need to assign each of load items to the member. And first highlight this uniform GX load and use cursor to assign and assign to member 1. Then escape. After that, highlight this nodal load in the Y direction, -3 kips, and use cursor to assign to node 2 and node 3. Then escape. After that, highlight this concentrated load, 6 kips, and 8 feet from member start. Use cursor to assign and assign to member 2. Then escape. Last, we highlight this concentrated load in the GY direction, 16 feet from the member start, and magnitude is -6. So use cursor to assign to member 2, and escape. So now we find that the scale of the model doesn't look good. So now we want to make the entire model look smaller. You just roll your mouse to change the scale. And next, we notice that the uniform load on member 1 is look very small. So in order to increase the magnitude, we want to do this. Put your mouse in the screen, right-click, then select Labels, and then choose Scales, this tab. And since the uniform force looks small, and for the load scales, distributed force, now we just change this number to a smaller number. And first, I try to make like 40 and apply, take a look. This increase a little, but it's not good. So I change that to 5 and apply and take another look. Now it's look reasonable, the scale, so I just click OK. Okay, so now we find we already done all the load items. And done with loading, and move to analysis. And for analysis, first we define command and just choose this no print and do add. We should see this perform analysis command show up in this analysis window and just close. And for shear moment diagrams, we do not need to do anything related to the post-analysis command. So now basically we complete the modeling process. Save your model, then hit this Run Analysis button. After that, we will choose Go to the Post-Processing mode to view the shear and the moment diagrams. Go to Post-Processing mode and down. And then for the load case, just hit OK. And now we enter the post-processing window. And today we're just interested in the shear moment diagrams. So we'll go to the beam results and maximize this window. And now we can roll our mouse to change the entire geometry of the frame, and then hold Control and roll the mouse to change the scale of the diagrams. And for the results, here mz represents the bending moment, and Fy is the shear force. For example, if I turn off this mz and turn on Fy, so now is the shear diagram. Again, hold Control, roll your mouse. You can change the scale of the shear diagram. Okay, so now we want to see the values on the shear diagrams. We will do this annotate and select the beam results. And for the bending, we check end and the maximum. Shear is end and the maximum. Then do the annotate. Just say OK and close. And now you can see the values on the shear diagrams. Okay. So on member 1, we have the maximum shear 12 kips, and on member 2 has the maximum shear as 6 kips, and the other side is -6, and on member 3, shear equals to 0. Okay, so now we change to the moment diagrams. First, turn off the shear and turn on the MZ. And this is the moment diagram, and you can see the shape as well as the magnitude. The maximum moment on member 1 is 90 kip feet, and on member 2 is 48 kip feet. And member 3, there's no moment on member 3. And all the values match our hand calculation, but for the moment diagram is opposite direction to our hand calculation, because the STAAD.Pro has a sign convention to draw the moment diagram on the tension side. So if the diagram on this side, and we know the beam bottom in tension. And for example, for member 1, if the diagram is on the left side, and we know the column, the left side is in tension. Another way to show the shear moment diagram is to use this layout. Then enter this beam results, and we select the graph. After that, we can take a look at the shear and moment diagrams for each member in this frame. For example, for member 1, and we have the moment diagrams and shear diagrams shown on the right side of the screen. And we can also maximize the moment diagrams and shear diagrams. Okay, and this is for member 1. And Fx means it's axial load in the column. And then let's take a look at member 2. And for member 2, this is the moment diagram. And shear diagram. And from the shear diagram, we notice that it's not for STAAD, there's a sloped line at a concentrated load, because the STAAD cannot have two values at the same point, cannot have the same shear, cannot have two different shear force at the same point. So that's why in the shear diagram it shows something that doesn't match our hand calculation, because that's the program bug. But it won't affect the maximum shear force, and it won't affect the results for structure design. And for member 2, axial load equal to 0. And now we move to member 3, and member 3, same as our calculation by hand, everything, the shear and bending moment equals to 0, but has the axial compression equals to 9 kips. Now we're done with today's example.